Hi, my name is Mrs. Greckle, and I'm a certified math teacher in Tennessee. Welcome to my seventh grade lesson. Today is lesson 5 in Module 1. In previous lessons in this module, we learned how to tell if two quantities are proportional using a table, and today we're going to look at that on a graph. So you're going to need a pencil and your student packet if your teacher provided you one. If not, you can just use a piece of paper so that you can follow along and work through the problems with me. You're also going to need something to draw a straight line with, such as a ruler. So you can use something like this, or if you don't have a ruler handy, then you can just fold a piece of paper in half or use the edge of something else to help you draw that straight line. If you need to, you can pause this video to go and collect those things. All right, let's get started. We're going to start out by looking at this example, which is the first one that's in your student packet. So Isaiah sold candy bars to help raise money for his scouting troop. And this table shows the amount of candy that he sold compared to the money that he received. So you can see in the table that right here lists if he sold 2 candy bars, then he received $3. If he sold 4 candy bars, then he received $5 and so on. Okay? All right, so my first question for you is the amount of candy bars sold proportional to the money that Isaiah received? And how do you know? I'm going to give you just a moment or two here and let you see if you can figure that out on your own. Okay, so what did you find? Are they proportional? Okay, all right, well, how do you find out? Well, we can use some of the same procedures that we've learned in the previous lessons. We can check to see if they're proportional by telling if the ratio for each one of these pairs of numbers is the same, right? Okay, so let's start. That first line, oh, wait a minute. Which way do I want to set up this ratio? Does it make more sense to write it as candy bars sold per penny or per dollar? Or does it make more sense to do it the other way around? How much money was received per candy bar? Okay, that might make more sense. All right, so let's try that. So how much money received per candy bar? So we're going to do 3 to 2 for that first line. Okay, and 3 halves, as we know, is the same thing as 1.5 or 1.5. Whichever way makes more sense to you is fine. Okay, so for the next row, we would set it up as 5 to 4. And that's the same thing as, well, I know 4 goes into 5 one whole time with 1 4 left over. So that would be 1 1/4, which is the same as 1.25. Okay, well, I can already tell that these ratios are not equivalent. So are these quantities proportional? No, they're not. So what does that tell us about these candy bars that Isaiah is selling and the money that he's receiving for them? Okay, I hear a couple of really good ideas. So it's possible that maybe Isaiah is accepting donations for the candy bars and they're not a set price. So each person might give him a little bit different amount of money. It's also possible, I think I heard someone say, maybe he's selling different kinds of candy bars and maybe they cost different amounts. So some small, some big, some have stuff in them, some not, whatever. But yeah, so that's a possibility too, and that would cause that change, right? And make it where the ratios are not the same. Okay. But for our next step, we want to see if we can come up with an example where the ratios are the same. So we want an example where they are proportional. Okay, so let's use the same scenario. We still got Isaiah out there selling those candy bars. But this time, in order to make it where the cost of the candy bar, or sorry, the candy bar sold is proportional to that money that was received, then we need to make sure that the ratios are the same. Okay. So that would mean in order for the ratios to be the same, right, we would want the amount of money received per candy bar to be the same, right? Okay, so let's look at just this first line here. If he sold 2 candy bars and he got $3 for that, what would be that unit rate? How much would each candy bar cost? Okay, we already said this earlier, right? We can set it up as a ratio, 3 halves, right? And that unit rate would be 1.5, and $1.50 would be $1.50, right? So for our unit rate, we know that each candy bar in this scenario cost $1.50. So let's go ahead and see if we can come up with some other numbers to put in this chart so that that unit rate stays the same. So we know he sold 2 candy bars and got $3. What if he sold 4 candy bars? How much would he get? Okay, couple of ways we can look at this. We can say, well, if he sold 2, he got $3. So if he sold 4, he sold twice as many candy bars, so he should receive twice as much money, or $6, right? Or we can use that unit rate like we've done in other examples and recognize that 4 candy bars at $1.50 each would be 4 times $1.50, or 4 times 1.5, which does indeed give us $6. Very good. Okay, so what if he sold 6 candy bars? Okay, same process. We can do 6 times 1.5, or we can get a little bit creative on this one and say, well, if 2 candy bars cost $3, 6 is 3 times the amount of candy bars sold, so it would be 3 times the amount of money that he received. And 6 times $1.50 is indeed $9. Very good. All right, so let's just go ahead and make this nice, a nice round number and say this one is 8. Okay, so then if he sold 8 candy bars, how much money would he receive? Very good, he would receive $12. So again, we can look back up here and say 2 times 4 is 8 and 3 times 4 is 12, or we can simply double those 4's and get 6 times 2, which is 12, or we can use our unit rate again. 8 times $1.50, which is $12. All right. So let's verify, first of all, in this table that the two quantities are proportional, right? Because that was our goal here, to make sure that we were coming up with an example where they were proportional. So is the value of each ratio constant? What is 6 divided by 4? Well, 6/4 is equivalent to 3 halves, or 1.5. Very good. Okay, what about 9/6? That is also equivalent to 3 halves. Okay, here, let me write that in there so we can see that. And then 12/8, which is also equivalent to 3 halves. Very good. Okay, keep in mind also, and we've talked about this again in previous lessons, but keep in mind, if he sold 0 candy bars, how much money would he receive if he didn't sell any candy bars? He wouldn't receive any money, right? Okay, so let's include that in our table, and we're going to include that in the graph as well. Okay, so before we start graphing, let's see if we can remember from your prior courses what we do when we graph. Okay, so first question I have for you is, there's a little thing in a graph called an origin. Who remembers what is an origin and where do you find that in the graph? All right, so the origin is where you start when you're graphing a coordinate pair, right? So you want to be sure that you start at that origin, which is 0, 0, okay? And then you make your movements from there. All right, let me ask you one more question. Why do you think that this particular graph only shows the first quadrant? Remember, there's 4 quadrants in an actual graph, right? But this one only shows us the first quadrant. Why do you think that's the case? Okay, good point, good point. If we look at the numbers that we're going to graph, we notice that they're all positive. In this scenario where we're talking about Isaiah selling candy bars, would we ever have a situation where we would not be looking at a positive number? Can Isaiah sell a negative number of candy bars? No. Can Isaiah receive a negative amount of money for those candy bars? No. Okay, so that's why we only need to look at that first quadrant for this particular data set. All right, so let's plot these points. Oh, almost forgot a very important thing. Before we can plot the points, we need to think about which variable, which quantity is the dependent variable and which one is the independent variable. So we can ask ourselves, is the money received dependent on the number of candy bars sold, or is the number of candy bars sold dependent on the amount of money that was received? Yeah, Isaiah had to sell the candy to get the money, right? So how much money Isaiah earns depends on how many candy bars that he sells. Okay, so the money received has to be the dependent variable. So that's why this is labeled Y here. This is the dependent variable. And the number of candy bars sold is the independent variable. All right. And when we're looking at our coordinate plane, where does that independent variable or the x go? Does it go along horizontally or vertically? Okay, so the independent variable is here. So these are our x's, or we refer to this as our x-axis down here. Okay, I'll put a little x out here at the end to remind us that's the x-axis. And I'm just going to write in, this is candy bars, whoops, sold. Okay, and then that means that the dependent variable is the vertical axis. We call that the y-axis. All right, and that is the money received. Let me turn my paper so I can write sideways. Money received. Okay. All right, so how do we plot that first ratio pair? We have an x coordinate and we have a y coordinate. And if we write that as an ordered pair, it looks like that. Look familiar? Okay, so the first number is the x, the second number is the y in an ordered pair. So remember, we start at the origin every time. And since the first number is the x value or the independent variable, then we're going to go along the x-axis first. And the second number gives us the y, So we're going to go along the y-axis second. All right, so 2, 3, so we start at the origin. We're going to count right 2 and go up 1, 2, 3 and plot that point. And we're going to do that with each one of these. So 4, right 4, up 6, and right 6, and up 9. Oops, went too far. There we go. And right 8 and up 12. And then don't forget we added this last one, 0, 0, because that is definitely part of our data set, just in case Isaiah doesn't sell any candy bars. Okay, so now's the time to pull out that straight edge or your ruler if you have one, and we're going to connect those dots. Oops, I went a little bit past it, but is that okay that I went a little bit past this one? Is it possible that Isaiah could have sold more than 8 candy bars? Yeah, he could have, right? Even if there's only 8 in one box, maybe he went and got another box and sold those too. So we can do this little thing and say that that can continue beyond the edge of our graph. Can we put that same arrow down here at this end of our line? No, no, because remember, if we go past the 0, 0, that's where we end up with those negative values that you learned about last year in 6th grade. So we don't want to put the arrow there. We want to recognize that our line starts at 0, 0 and can continue in that direction. All right, so what do you notice about this graph? Is it a straight line? Is it a curved line? Does it jump around? What do you notice? And where does it fall on the graph itself? Okay, so I'm hearing that it is a straight line. So let me just jot down what our observations are. All right, so we see that this is a straight line, right? And I heard someone say it starts at the origin. Okay, so it starts at the origin. Okay, very good. Those are some good observations. So do you think, remember when we created this table, we said that we wanted one that was proportional. So this is a good graph to represent what a proportional relationship looks like graphically, okay? So do you think that all proportional relationships will form a straight line when they're graphed? Okay, well, maybe we need to think about that just a little bit more, but I'm hearing some good thoughts. Okay, so do you think that all proportional relationships are going to start at or pass through that origin? Oh, you all are remembering some of the lessons that we had before, right? Some of those prior lessons actually we talked about what happens when 0 is part of the problem, right? So for example, I remember a problem about comparing cups with ounces in a kitchen, right? And so if we have 0 cups, how many ounces do we have? 0 ounces. So there's a proportional relationship. If you recall, that one was proportional. That was the one with the number lines. And 0, 0 was part of that. And of course, in this situation, when Isaiah sells 0 candy bars, he gets $0. And so that one is proportional and it does pass through the origin. So maybe there is something to that. So we're going to do some exploring a little bit more. So right now, if we want to think about the characteristics of graphs of proportional relationships, right, we're thinking about something that makes a straight line and something that starts at or passes through that origin. All right, so Let's look at this example. We're actually going to go back to that opening exercise. This is actually the same table that we had in that very first exercise. I'm trying to find where I had it written down. Here it is. See how it's the same one? Okay, so we're going to go back to this one. If you recall from our opening exercise, was that relationship proportional? No, remember, because the ratios were not equivalent. So what do you think this one is going to look like on the graph since it's not proportional? What do you think, it would still be a straight line? Do you think it would still pass through the origin? All right, let's try this and see what happens. Okay, so we're going to go through the same steps that we did before. The first one is 2, 3, so we're going to start at that origin, and again, we're going to go along the x-axis first and then to the y. So we're going to plot the point 2, so right 2 and up 1, 2, 3. And then for 4, 5, we're going to go right 4 and up 1, 2, 3, 4, 5. And then 8, 9. So here's 8 on the x-axis, and I'm going to go up to 9, which is right here. And then the last point is 12 and 12. Let's see. Yep, that looks good. Okay, and don't forget that we also can say, even in that original example, Isaiah was selling candy bars, right? So if he sold 0 candy bars, how much money would he get? He still wouldn't get any money for the candy bars, right? So still $0. So 0, 0 is still an option. Okay, so now we're going to use our straight edge again, and we're going to connect those dots. So what do you notice about this one? Yeah, it's not a straight line anymore, is it? Did you notice how I had to move my straight edge so that I was sure that I passed through every point? And if I just line up those first two, none of the rest of the points line up with my ruler. So I know it's not a straight line. It does, however, still pass through the origin. So what do you think that that means? All right, so if we're looking at a graph that represents a relationship between two quantities and the line is not straight, regardless of whether it goes through the origin, right? Then is that relationship going to be proportional? No, because for it to be proportional, we're thinking it has to have that straight line, right? Okay, so this one is not proportional, at least that's what I'm hearing you say, based on the graph, because the graph is not a straight line. Okay? So how else can we verify, right, that this is not a proportional relationship? Right, we can use those ratios, but we've already done that with this problem, right? We've already said that this one was not proportional because the ratios were not equivalent. So very good. All right, let's look at one more example. Okay, so this time we're not really given a scenario. This one we're just looking at some points. So let's start by plotting these points on the graph, okay? So we'll start with 0, 6. So to plot that point, here I'll write it here so you can see what it looks like as an ordered pair. So again, we're going to start at the origin. And the x-coordinate is 0. So do we move? Do we move to the right at all? No, because we don't. It says move to the right 0 places, right? So we're not going to go to the right. But then the y-coordinate is 6, and so that means we're going to go up 6 and put our point. Very good. Okay, so what about 3, 9? So start at the origin, 1, 2, 3, and go 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, look what I just did. This scale is different, isn't it? The scale is going by 2s. I caught it on that one because I just looked at the 6, but I didn't catch it on this one. I need to be sure I pay attention to that, don't I? All right, so if I count to the right 3 and I'm going to go up 9, well, 9 falls in between 8 and 10, doesn't it? So that means I need to go up to halfway in between 8 and 10. So there's 3, 9. Okay, so then 6, 12. I'm going to go right 6 and up to 12, which is right here. Which lines up with that 12. Okay, and the next one is 9, 15, so right 9 and up. 15 falls between 14 and 16, so that would be about right there. And then 12, 18, so right 12 and up, and 18's on there, so I can go up to that. And there's my last point. Now, since we don't have a scenario, we cannot say 0, 0 is part of this graph, correct? All right, but we can use our ruler and we can connect those dots. Well, they look pretty straight to me. What about you guys? Okay, I agree. So it's a straight line, right? This is a straight line. But what's different about this graph from that other one that we did? Let's see if I can find it real quick. Here it is. What is different between these two graphs? They're both straight. Oh yeah, this one went through the origin, right? This one goes through the point 0, 6 and does not pass through the origin. Okay. So straight, but does not pass through origin. Does not pass through or start, right? The origin. Okay. So what are your predictions? Do you think that this is a proportional relationship between these values in the table? Well, how can we verify to be sure if this is a proportional relationship? Yes, we can compare those ratios. All right, so let's do that. So let's do 6 to 0. Uh-oh, we can't divide by 0. So we can't really use that one as an example, right? Because it doesn't give us any information. Let's try the next one. 9 divided by 3. Okay, that one we can divide and we can see that it's equivalent to 3. And this one is 12 to 6. And 12 divided by 6 is 2. Oh, look. Those ratios are not equivalent. So it is not proportional. All right, so think about the examples that we've just looked at. Remember, this one was our proportional example, right? This was Isaiah selling candy bars for the same amount per candy bar. So this one was proportional. We ended up with that straight line that passed through the origin. Okay, and then we looked at this example. This was our first example where we were determining and we said, no, it's not proportional, right? It's not proportional and it was not a straight line, even though it did go through the origin, right? This one was the one that was definitely curved. You see that? Okay. And the last example, well, this one is a straight line, but it did not pass through the origin, and it was also not proportional. So you should have this in your student packet. It may have been mixed in the problems, but let's go ahead and fill this out now. We want to know specific characteristics of graphs of proportional relationships. So what is one? Yes, it has to be a straight line in the graph. Okay, and what else did we find? It has to pass through the origin. So when you are looking at graphs of relationships and you're trying to determine if they're proportional relationships or not, then you can tell simply by looking to see, is it a straight line or not a straight line? And if it is a straight line, does it pass through that origin or does it start at this origin? Okay, and if the answer is yes to both of those, then you know it's a proportional relationship. If the answer is no, to both of those, then it's not. Okay. So good job, guys. You all have done a great job today. And I really, really appreciate your hard work with me today. So thank you. Good stuff. Remember, you can always go back and rewatch any parts of this video if you need to, and your teacher will let you know about your next steps. I hope you have a wonderful day.